Welcome to qnawire.
In this problem, we're given two different molecules, and we're asked about the number of chemically non-equivalent hydrogens. So this is going to be important for proton NMR. It will tell us how many signals we should ideally expect to see. So for this, we're looking for the same chemical environment. So if we look at our first guy here, and we draw in all of our hydrogens, so we know that hydrogens that are on the same carbon here will have the same shift, so they'll be chemically equivalent. The question is whether any of these groups are equivalent to each other. So we look at chemical environment. We're next to a methyl group here, and we don't see that for any of the other hydrogens. So this is going to be one type of hydrogen. Here we have two CH2 groups on either side, but we don't see that anywhere else in our structure. So that's another unique hydrogen. Here we're next to a CH2 and a carbonyl, and that's unique. Then this guy is on a doubly bound carbon next to a carbonyl and a methyl group. That's unique. And then our three hydrogens here will show up in the same peak. So we see 5 signals here, or in other words, 5 non-equivalent hydrogens. For 2-methylpropene, we're looking at this structure here. So we have CH3 groups here. And this gets a little tricky because if you're in an intro course, so something like organic chemistry, here we say that these 2 methyl groups are equivalent and these 2 are equivalent. So we'd have 2 signals or distinct hydrogens. But if you're in a more advanced spectroscopy class, these hydrogens won't be chemically equivalent. And often we'll say that these 2 won't either. So we'd say that really there's 4 signals. Here, you're likely in an organic chemistry class, and 2 signals is what they're asking for.